Okay. All right. So we're doing border problems today. So Mrs. Smith, the taskmaster, has a very specific instructions for getting an area rug for our living room. So my living room, roughly, is 12 feet by 10 feet. I just chose nice round numbers. I think it might be a little bit bigger than that, but we're just making the numbers nice and manageable to work with. But not any area rug will do. The area rug we get has to have a uniform border around the outside of the room. So that just means that the rug will look kind of symmetrical. Like the distance from the rug to the wall, all around the room is going to be the same. So a nice uniform border. But then she doesn't want the rug too big or too small for whatever reason. She wants the rug to basically take up 2/3 of the room. So if we can just digest what we're being told here, hopefully it's not too much of a stretch to realize that the area of the room, like the total area of the room, is 12 times 10. It's 120 square feet, right? And then the rug needs to be 2/3 the area of the whole room. So 2/3 of 120. I think we could all do the mental math here. A third of 120 is 40, which makes 2/3 80. So the rug's area has to be 80 feet squared. You guys okay with the premise there? So we need a rug that covers 80 square feet of the room, but leaves that uniform border. There's many rugs I can buy that have an area of 80 feet squared. I could buy an 80-foot long rug that's 1 feet wide, but that'd be a pretty silly rug to have. Wouldn't look nice in the living room. Or I could have a 20-foot by 4 or 5 by 16, but there's one specific rug that will give us that nice uniform border. So how do we find it? I'm going to show you guys how we do this. So I've got a nice visual here, and then I'm going to talk about, after we set this up, what my expectations for these kind of problems are for the 3M people versus the 3U people, according to what their curriculum says. All right. So yesterday you guys did solving by factoring. So what we have to do here is set up an equation that'll help us find that specific area of rug. And the way we're going to solve that equation is to solve by factoring. So we'll start with this. We need a variable that we're going to solve for. We're actually going to let, if you guys would jot this down over here, we're going to let x be the uniform border width around the rug. That's what we're going to choose. We're not going to let x be like the width of the rug or the length of the rug. We're actually going to choose to let it be like the width of that border. And then if you guys would add to your diagram with me, I'm just going to put on every side here just these little double arrows and an X, just indicating that on every side of this rug, we have a border width of X. All right. So that's step one. Step two here, I'm going to just label the dimensions of the whole room on my diagram here. So I think I'll do on this side, because I have some room. I'm just going to say, okay, that length of the living room is 120 feet, or sorry, 10 feet. And then let's do on the top, I'll say the whole room, 12 feet. That way. All right, so we're going to build an equation here for the area of the rug. So the starting point of our equation here is not too bad. We're going to start with just area equals length times width. And then from that, we're going to build an equation for the area of our rug that we can solve. All right, let's plug in what we know. Area of the rug, we already talked about that. The area of the rug here is 80 feet squared. So we'll plug in A for A equals 80 there. We don't have an expression for the length, and we don't have an expression for the width. So we're going to add some things on to our diagram here. I'm going to switch to a different color, but you don't have to. All right, so here we go. We need an expression for the length and width of the rug. So notice here, I'm just saying, I'm setting up, this is just going to be an expression for the width of the rug. So we can just eyeball this. Look, guys. So if the whole room is 10 feet, and we have to take away the border on every side, then wouldn't an expression for the width of the rug, it would just be the width of the whole room, 10, minus 2 times whatever the width of the border is. It's just 10 feet, and then you have a border on each side, right? So if the border was 1 foot, you have 10, and you would take away a foot twice, and the rug would have to be 8 feet. You guys, we digest that? We got okay with that? It's kind of the key to the setup of the question. And then, in the same way, what's an expression for the long side of the rug? Well, the whole room is 12 feet, and then on either side, you have to take off the border. So an expression for just that long side of the rug, I'll put it down here, would be 12 minus a border on each side. So 12 minus 2x. And so we have an equation that represents the area of the rug. So the length is 12 minus 2x, and the width is 10 minus 2x. And if we could figure out what x is, then we would have the border, the dimensions of the rug that I need to go by. So what we've done here, we've set up an equation, and then you guys from yesterday have the skills to solve. We're going to solve that by factoring. But before we actually do that, I just want to make sure expectations are clear for both classes. So for my 3M people, you're going to explain. So I would give you the setup, give you the equation, and you explain where the equation comes from. Sorry, I haven't been teaching for 2 days, so my fine motor skills suck even more than normal. For the 3U people, you will have to derive the equation. You will have to do what we just did. Okay, so the 3M people aren't out of the woods. You need to be able to explain the pieces of the equation and where they come from. But the 3U people, I'll give you the question, and you have to kind of derive things. That's just the expectation for the 3U course. But everybody, both courses, have to solve this level of equation. So let's dive in. So yesterday with Ms. Plattner, you guys saw we can solve equations by factoring, but everything has to be on one side. Everything has to equal 0, so we can solve, so we can factor and set each bracket to 0. So you guys have some expanding and simplifying to do. We got to do these 4 multiplications. And at this point, I truly believe everybody here has the skills to do this. No individual step here is overly complicated. There's just a few steps. So we have 12 times 10, 120. 12 times 2x, or negative 2x, so minus 24x. Minus 2 times 10 is minus 20x. Minus 2 times minus 2 plus 4x squared. We got to collect everything on one side so that we can solve by factoring. Let's do this all at once. Collect all the like terms. So I'm going to put everything on the right. I'm not your dad, though. You can put things on the left if you want to. So we have a 4x squared. And then we're collecting the x terms. So we have negative 24 and negative 20, negative 44. X, and then we have 120 and the 80. We're not going to add those together. When we move the 80 to the right, we're going to be subtracting 80. So if you need that Q, you can maybe put a minus 80 there. But 120 minus 80 is 40. And now we have a quadratic equation. Everything's set equal to 0. And so now we can factor and solve for x. And this is the whole point of me doing those choosing a strategy warm-ups with you guys. So you would run through the checklist, and what was the very first question you guys had in that little 3 questions to ask when choosing a strategy? You should look for a common factor first. Those are kind of big numbers to work with, but if we look for a common factor and 4 goes into everything, then things become quite manageable. So we're left with x squared. 44 divided by 4 is 11, minus 11x. And then 40 divided by 4 is 10. That's a simple trinomial. Should be a piece of cake for you guys after we've done 5 or 6 days of factoring now. Look for numbers that multiply to 10, add to minus 11, and then we'll keep moving and find out our border width. Two brackets, x and x, multiply to a positive, add to a negative, so both are negative. And be 1 and 10, right? 1 and 10? 1 and 10. The new thing Ms. Plattner did with you yesterday is that when solving a quadratic equation and you have a bunch of things multiplying to 0, when things multiply to 0, at least one of them has to be 0. So we get one solution by asking, hey, what makes x minus 1 equal to 0? That's not too overwhelming of a linear equation to solve. X equals 1. And then from our second one, we ask, hey, what makes x minus 10 equal to 0? And we get x equals 10. 2 possible values for x. 2 possible values for the border around our room. Now, can you guys have a think for a second? I'm actually going to do my attendance while you guys have a think on this. Does this mean there are 2 possible border widths or 2 possible rugs I could buy? One that satisfies this, one that satisfies this? Or do only one of these answers make sense? Remember, x represents that width of the uniform border around the room. So you guys think on that. Or do we have 2 possible answers, or does one kind of not make sense? I'm going to pause the video. All right, guys, and we're back. So, you know what? I think we've had enough of my face. I need the space. Which one makes sense here? A 1-foot border, a 10-foot border, or do they both make sense? What do you guys think? Anyone want to take a stand? Colette, what do you think?
1-foot border.
If that's the only answer that makes sense? Colette says 1-foot border fits the bill. What do you say, Forrest?
It just doesn't make sense because one of the sides people take orange, basically making it orange.
Yeah, if the room is 10 feet wide, then it's impossible to have a uniform border of 10 feet around the room, right? The room's only 10 feet. Actually, a border of 10 feet would be like 10 and another 10. It's bigger than the whole room. So down below, you might just X this out. And then just as to why we are Xing it out, we can just make a little note. It's bigger than the room, that border width. Doesn't make any sense. And so we solved the problem. For me to get the perfect rug for Mrs. Smith, I need a rug that gives a 1-foot border around the room. So what is that for my length? Remember, the length is 12 feet of the room, and we'll subtract 2 of those borders. So 12 minus 1 and minus 1 again is a 10-foot rug on one side. And then for the width, 10 feet minus that 1-foot border on each side. 10 minus 2 is 8. And then lastly, last time I checked, 10 times 8 gives you 80, right? This rug does have an area of 80 feet squared. It fits the bill. That's the rug I need to get for my wife. That's a border problem. So solving the problem, the math skills, you guys have all the math skills. We reviewed factoring and learned factoring. You did solving by factoring with Miss Platter. For the 3U people, you maybe even set up some border problems last year. I don't know. But yeah, now we have one under our belt. We're going to do one more with a bit less guidance from me, maybe moving through it a little bit quicker. And then, then we'll get you guys working. So a similar problem that for you guys to try setting up. I'm putting a uniform walkway around my backyard this time. Backyard is 15 by 12 meters. This time, hello. You know what? We're doing some really important stuff. Can you come back later or another day?
Yeah, sure.
Okay, thank you. This time, instead of saying the rug is 2/3 the area of the room, Mrs. Smith just said, hey, look, we need 108 square meters of grass left over. So it's a very, very similar problem to the last one. I'm gonna give you guys a bit of a head start. Can you guys give this one a go? I'll kind of like play catch up along the way. So don't just wait for me and then copy out what I'm doing. See if you can set this one up yourself. Whole backyard's 12 by 15. Can you get an expression for the length and width of the leftover grass area? Oh, it doesn't show up at all. Okay, I've given you guys a bit of time. It's the same setup as last one. For the grass area, its area is 108. An expression for its length and width would be 15, the long dimension, minus 2 borders, and then the small dimension 12 minus 2 borders. And then the solve is the exact same steps as the previous one. Expand everything on one side, and then use an appropriate technique to factor. So I'll wait. Yeah, maybe I'll do the expanding with you guys. $15 times 12. 15 times 12. 119. All right, I caught up. I did all the expanding and collecting my terms. I got this. How about you guys? All right. So, just like High School Musical, we're all in this together. This one looks a little intimidating. You guys are familiar with High School Musical? Okay. Anyway, yeah, the numbers are pretty beefy in this one. Let's work together here. Let's walk through the checklist. Any common factor we can divide out? Kim? Yeah, well, we can take out 2 to reduce things further, make the number smaller. So let's do that together. And what is left? 2x squared minus 27x plus 36. Unlike the previous question, by dividing out this 2, we are not left with a simple trinomial. It's not a perfect square trinomial. It's not a difference of squares. We have to use the Australian method to do this one. We are looking for 2 numbers that add to minus 27 and multiply to 2 times 36 and multiply to positive 72. So if you guys can have a think on that, put your collective minds together. I'll set up my Australian method factoring here. So we have that 2, and then we're factoring that trinomial 2x, all over 2, a minus and minus. And then this is actually going to be an example of why the Australian method is like so good, in my opinion. Now I think I heard the 2 numbers. But if you guys were doing this on a test and you weren't sure, you would just start grinding. Grinding is a word you guys know. You guys use the word grinding now. No? You just start from the top. You do 72 divided by 1. That's 72. So 1 and 72, they can't help you make 27. And then you do 72 divided by 2, and you try that, and you get 36. 2 and 36, you can't make 27 from those guys. Then you do 72 divided by 3, and you get, what do you get? 24, right? And look, 3 and 24, we can make 27 with that. So just use your calculator and just start grinding, and you can often find the numbers that work pretty quick. So it's minus 3 and minus 24. Now here's why the Australian method is so good. Like normally, if I just asked you guys to factor, you would look into 2x minus 24 and divide by 2 again. But if we're just solving by factoring, we're just saying, hey, this times this times this divided by this, if this all equals 0, well then one or both of these brackets just have to be 0. I actually don't have to do anything else. I can just go right to setting my brackets equal to 0. So that's what I'm going to do. I'm just going to go right to, okay, what makes 2x minus 3 equal to 0? And then what makes 2x minus 24 equal to 0? So one advantage of the Australian method, solving by factoring, can be a bit easier. You guys are to get two answers here, and you just have to ask, does one make sense, or do both make sense? And then we'll wrap it up. I think I'll just do it with you. So 2x equals 3. I'm okay with decimals here. 3 divided by 2, or fractions, whatever you want. 3 divided by 2 is 1.5. So 1.5 meter border. Now, immediately, I'm thinking that sounds realistic. And then I'll solve the other bracket equal to 0. 2x equals 24. 24 divided by 2 is 12. Now, a 12 meter border sounds unrealistic given the dimensions of my backyard. My backyard is only 12 by 15. So in the same way, that's an inadmissible solution. But you guys can just say, you know what, it's too big. So essentially, guys, we've solved the problem. This question asked us for how wide should the walkway be. So we're actually done. The walkway should be 1.5 meters wide. .5 meters wide. Nice. The rug question, my wife wanted the dimensions of the rug, so we had to find that length and width, but this one we're golden. All right, I've done 2 border problems with you guys. Step by step, showed you everything. You guys are all doing a common assignment here, so solving by factoring, with one border problem where, because I'm so nice, the kind of guy I am, I've set it up for you guys. With 40 minutes, I think we could, a good goal would be to have this done. It's like 3 pages front to back, so I'm trying to get this done. Yeah.
That's not how I told it. I
All right, let's get this done, guys. 20 minutes, lots of time.
I said thank you. Bro.
And one more time, this assignment's the same for both classes, so feel free to, you can collaborate with anybody. Oh, just need a calculator? Yeah. And one last thing for you guys, for question 4 for the border problem, even though I set it up for you guys, if I were in the 3U class, I'd actually maybe set it up myself so that you're confident in doing that, because I won't give you the equation on an evaluation. We're just building up to that.